1, Chapter 2, Lesson 3, multiplying radicals. So we talked about in the very first lesson, you can multiply radicands. They just have to have the same index. So you can multiply the insides. You just can't add them. And that's why we did adding has to be the same yesterday or on Friday. Okay. So just for quick, I'm not going to make you go through your calculator here just for the sake of time. Root 2 times root 3 is root 6. Okay. They both have an index of 2. You can multiply the 2 times 3. It is root 6. Okay. 2, now you gotta kind of think about this also as kind of like terms. Multiply the coefficients. Come on. Oh, we'll try this again here. Multiply the coefficients and then multiply the radicals. So 2 times negative 4 is negative 8. Root 5 times root 3 is root 15. So that one is good. What do you think's wrong with C? Yeah, different indexes. So this one's not good. Okay. We have 2 cube root 10 times 3 cube root 7. So they're both cube roots, so we're good there. 2 times 3 is 6. Cube root 10 times cube root 7 is cube root 70. That one's good. Right, and this one right away, different indexes are concerned. They even multiplied the indexes, got a little bit crazy, which you can't do that either. So this one's not good. The indexes are not the same. So based on the results, write a rule. Multiplication of coefficients and radicals must have same index to multiply radicands. Okay. Must have the same index to multiply radicands. Okay, you can put that in your own words too. You have to copy down what I put down. Okay, so moving forward here. All right, so the multiplying radicals, there it is essentially. Multiply numerical coefficients by numerical coefficients, radicand by radicand, if the indexes are the same. Simplify into mixed radical form if possible. So now we're just do a bunch of examples to close out. Like I said, we don't have much today, just mostly examples. Okay, so one thing you'll kind of find out, whenever you multiply a radicand by the same exact radicand, it's going to give you just that number, but we'll do it one time. Root 8 times root 8 is root 64. Square root of 64, of course, is 8. So whenever you multiply like root 6 times root 6, it's just 6. We're going to use that to our advantage when we talk about conjugates later. Okay, but that's root 8. So then here, 4 times 3 for 12. 5 times 6 for root 30. Root 30 can't break down this time. Four times 3 for 12. Root x times root y is root xy. We don't know what they are. You just put them as a product. Just root xy. And the last one here, negative 2 times 5 for negative 10. 8 times 12 is 96. 96 can break down this time. 96 breaks down to 16 times 6. 16 comes out as 4. Negative 40 root 6 is our best case for that problem. Okay. All right. So expand and simplify. So the biggest thing here is we are distributing here. So you have a bracket with something on the outside. So it's going to go like this and like this. So for example, the first one's going to be, there's no number here, so it's just a 1. So the 2 just stays at 2. Root 5 times root 10 is root 50. Whoa. Root 5 times root 10 is root 50. Okay, and then we have root 5 times root 5 is just 5. Okay, you can write root 25 if you want. Okay, 50 breaks down to 25 times 2. Pull out a 5. Simplified version is 10 root 2 minus 5. Okay. B, we're going to distribute this one as well. Now, there's a couple things I'll tell you is that you can distribute now, or you can see how 45 and 20. 45 and 20 can be broken down. So if you break them down, your multiplication in gets easier. Because if I go 5 times 45, we're talking about 225. Okay? Even though it's a perfect square this time. Okay? So I don't care how you do it. I'm just going to break these down first. Just so you guys get in the habit of when you see stuff you can break down, you do it to make your numbers easier. And so what that's going to change this to is 2 root 5 times the 3 comes out. So it's 9 root 5. We'll keep that 8 root 5. And then this comes out 2 root 5. So 2 times 3. And see what actually happens. It even gets easier. Sorry, pen's kind of jamming today. It's even easier because look, all the stuff inside here is a what? Root 5. So we can combine that to one thing now. We don't have to distribute 3 times. Is it 9 minus 1 plus 6? So it'd be 7, wouldn't it? Yeah, so 7. So 2 root 5 times 7 root 5 is what we have. Okay, everybody follow that? So we simplified. They all became the same radicand and index, so we can combine with addition and subtraction. 7 root 5, and so now it simply is 2 times 7 is 14. Root 5 times root 5 is just 5. You get just the number 70 here. So all of that turned into a nice clean number of 70. Okay. All right, let's try these two here. So these ones here, there's nothing to break down, so we're going to distribute. So I get 2 root 3 minus 2 root 5. So we get 2 root 3 minus 2 root 5. Distribute, that is a negative, just so you don't have to worry about the minus sign going away. So negative root 2 times negative root 6 is negative root 12. Negative root 2 times root 10 is negative root 20. And now we can see we can break those down. The 12 is 4 and 3. 20 is 4 and 5. And so we get 2 root 3 minus 2 root 5 minus 2 root 3 minus 2 root 5. A little bit interesting here because the 2 root 3's go what? Away. And then negative 2 root 5 and negative 2 root 5 is negative 4 root 5 is all that's left. Okay. This last one's variables here for this set. Negative 4 root a times root a. Negative 4 times negative 9 root b. Negative 4 root a times root a is just negative 4a, because the root a times root a is just a. Negative 4 times the negative 9 is a positive 36. And what's next? Root ab, yep, root ab. Has to stay in a root because we don't know if they're the same or not. Okay. All right. And area now. So we did perimeter last time. We were doing subtraction. Now doing area. So area we know is length times width. So we're going to multiply these. In this case, you have to use your Math 10 skills and be able to FOIL. Okay, so we have to go ahead and FOIL this out. So people get lost with radicals and they have to do, foiling and things that are a little bit uglier. 4 times 7, 28. 4 times negative root 6, negative 4 root 6. Root 6 times 7, 7 root 6. Root 6 times negative root 6 is a negative 6, because root 6 times root 6. Now we're just combining our like terms. 28 minus 6 is 22. Negative 4 root 6 plus 7 root 6 is 3 root 6. So the area of that figure expression would be that. So they only give me one side here, but that's okay because why? Right, they're all equal. It's a square, right? So we know it's just that times itself. The other thing, what jumps out with you with the side lengths here? Yeah, they're all the same, so I kind of said that wrong. What jumps out with you about these two values? Sorry. They can be broken down, right, Chris? So I can break those down. So let's do that, because I don't want to go root 18 times root 18. Okay, that gets too big. So let's break these down to make them simpler now. 9 times 2 and 9 times 3. So 9 comes out to 3. We get 6 root 2 minus 3 root 3 now is what we have. And then we'll go ahead and multiply that by itself. 6 root 2 minus 3 root 3, like this. 6 root 2 minus 3 root 3. Interesting pen, sorry. Sorry, it's not like my handwriting was good before. So now we're just going to go ahead and FOIL these out. So we get 6 root 2 times 6 root 2 is 36. And since they're both root 2's here, it's just a 2. Does that make sense? It's 6 times a 6 for the 36. Root 2 times root 2 just for 2. You can write root 4 if you want, but you'll probably get tired of it. 6 root 2 times negative 3 root 3 is negative 18 root 6. And I get the same thing here. I get negative 18 root 6 again. And over here I get positive 9 times 3. And now we're going to combine. So we get 72 plus 27 here, which is 99. And then we have negative 13 root 6. Sorry, 36 root 6. I know I said 13. Negative 36 root 6 there. Okay, really organized here. Just making sure you're staying organized in your work's really important. The like terms and the radicals, you'll learn to work with them. But yeah, it's not too bad. Okay, last piece, we're just going to talk about conjugate really quick to kind of set this up for division as well. So multiplying the conjugate binomials. So we're just going to talk about what conjugate means is simply the same expression but opposite signs. Conjugate means the same binomial but opposite signs. So 5 minus root 2's conjugate is 5 plus root 2. And we're going to do this because we're going to notice what happens when we do this. Because this is going to help us again for division. Root 5 times root 5, guys, is just 5. Root 5 times root 2 is root 10. Negative root 2 times root 5 is negative root 10. Negative root 2 times positive root 2 is minus 2. And then I heard somebody say it already. Yes, this is the important part. It gets rid of the radicals for us. This cancels. We have simply 5 minus 2, guys. That's 3. So when we want to rationalize and get rid of our radicals, we're going to use conjugates to help us. Okay? At least on the bottom. We can't get rid of them completely. Okay, we'll do one more here. 2 root 7 times 2 root 7 is 4 times 7. 2 root 7 times negative 8 is negative 16 root 7. And I get plus 16 root 7. And I get minus 64. So I get 28 minus 64 for this one, which is negative 36. Because the middle cancels, right? This is what do you notice about them? And this we'd say that the inside cancels, and that eliminates the radicals. Okay? All right, so with that, I want you guys to try this here, try these three, and then I'll come back and we'll finish them and make sure they're good. Multiply by the conjugate for all three of these and see if you can get them to clean up there. All right, so just working through these two. First thing is got to figure out what the conjugate is. It's just the same expression, opposite sign. So 4, 6 plus 3, 4 root 6 minus 3. So this one would give me 16 times 6. Now, you can do the middle if you want continuously, but once you understand it's going to be gone, I don't require you to show me that. So what I'm saying is the middle should cancel every time. That's the point of the conjugate. So you don't have to keep showing that over. I'll do it one more time, but I won't show it for the last two. So 4 times, that's negative 12 root 6 plus 12 root 6 minus 9. So then these go away. 16 times 6 is your 96. Minus 9 is your 87. Okay? So let's try this one. Now don't be psyched out by the negative there. We're just going to focus on them being the opposite, which just makes this negative 3 root 11 minus root 2. We don't change both signs. It's only the middle. Okay? It's only the middle. So negative 3 times root 11, that's going to be 9 times 11. Again, the middle is going to cancel, so I'm not going to do that. Root 2 times negative root 2 is just minus 2. We're looking at 97 for part B. And the last one, just going to go this, times 5 root x plus root y. We're going to get 25x minus y, because the middle is going away. Okay? All right, so that's it.